Hello, guys. Nice to see you.
Good afternoon.
Hello.
Hi.
Hello.
Hello. Hello.
Hello.
Good morning.
Hi.
Hello.
Hello. Hi.
Mhm.
Hello.
Hi, guys.
Good afternoon. Hello. Hello.
Let's maybe wait 1 minute so more people join, and then we will continue. So, how your semester started and what concerns you have, what hopes for some positive changes?
Everything is great, пока.
Mhm. Okay, that's cool that you have such optimistic attitude. Hopefully you will stay so optimistic for a long time. I wish you very good luck with your start with at Nazarbayev University.
I wish so as well.
Thanks. Yeah, before first midterm, everyone is happy, that's true. But after second midterm, it's getting better, so don't worry. Usually first midterm, not so easy to digest, but then you will be more accustomed. Okay, guys, so I believe that most of you who were planning to attend this discussion are already here. Let's start from maybe your questions. If you have any questions regarding the organization of the course and some technical aspects of our work during this semester, so we can kind of smoothly transition and like continue our previous conversation and discussion of the course and introduction to the course. So I believe, okay. Okay, we have some questions in the chat. Do we have recitations this week? That's a good question. Unfortunately, I don't know answer to this question. I guess it should be according to schedule, because in registrar you should have scheduled your classes. And if it is scheduled, then I believe it should be there. Attendance is not mandatory. Yes, attendance is not mandatory, but very much recommended. Depends on your professor. I don't know what depends on my professor. And I don't have my personal professors. So I believe that maybe recitations depend on the decision of the instructor, but in any way, it should be according to the schedule. You definitely can contact the instructor who is leading recitations for your section. That is the best approach to do it. I can be responsible for our online discussion sessions, and these will be 3 times per week on Monday, Wednesday, and Friday. For your section number 3 will be at 12 p.m. I also have section number 4 just right after you guys. With Moodle, well, first of all, it's changing, and my personal experience working with Moodle last year, I didn't work very much with Moodle, but I figure out that it's kind of time consuming without some clear benefits of really using it. So we will use it for preliminarily sending final grades. That's for sure. That's kind of mandatory part. We will need to use Moodle to submit preliminary final grades for your information, and afterwards it will be officially put in a registrar. However, besides that, it is really way more convenient and efficient way to communicate via emails, because again, from my personal experience, there were some issues when I was sending emails where like notifications were Moodle to all students in my section. For instance, it was reminding of the like midterm. Actually, it's not necessary because all information is available in the manual of the course. However, decided to remind students about the upcoming midterm, and then quite many students complained that they didn't receive this message, and never happened with sending emails via registrar. So registrar is really official website of University, Algebraic University, and there we keep actual information which really works for us. So that's why I believe it's more reliable to use registrar list of students for automatic sending emails notifications around the students. Okay. Any other questions? So let me remind that just short reminder from the previous discussion that keep in mind we have 3 components of your final grade. That is okay, let me finish my statement, then I will answer this question. So there are 3 components of your final grade. First is homework assignment weekly, 20% of contribution towards the final grade. Another 20% from laboratory work, which is also important and should keep an eye on this. Don't miss laboratory works, because then it will be way more difficult to organize like repeat of this laboratory work and late submission. You will lose points, so that is better be avoided. And also, of course, the main contribution to your final grade is defined by your performance during midterms, like 3 midterms and a final exam, which equally contribute to your final grade. So there's one more question. Where and how we will be completing weekly assignments? Yes, sure, I can explain this. As mentioned during our previous discussion, all weekly assignments will be carried out via long couple. So you will receive about 10, 12 problems per week, and in long couple you will solve them and provide just numerical answer with units. Also, long kappa will be organized all midterms and final exam. So that is how we are going to work, and this is our main platform which will evaluate your performance. That's why, again, that is very critical moment. Please check very carefully requirements from the long kappa in order to submit your answer. Please, guys, you can switch off your microphone if you're not talking, so we don't have this background noise. Thank you. And in order to avoid losing points and getting some troubles during the midterms or exams, please submit your answers according to the rules of long kappa in the required format. Okay, I see you have fun already in the discussion. So if besides these encrypted messages, you have some real questions, you're welcome to ask me.
Can I have one question?
Yes, of course.
In the previous lecture, you told us that we are yet not able to enroll to the long kappa, so we should wait for the end of the week, yes?
Yes, sure. Don't be in rush so far because you don't get any homework assignment this week. And it really takes some time to manage the list of students. So currently we have, it hasn't been yet settled because certain students are still trying to shuffle between the sections. And in order to get starting with this form, creating accounts for in long kappa for students, we need to have final list of students per each section. So far, it's not ready yet. Some changes are going on. Best to my knowledge, what I heard that there is some trend in requesting sections from 1 to 4. I believe it's just because they are earlier. And there are less students who are willing to be in sections 5 and 6. However, we need to have some balance between sections, and that's why it will still take some time. But once we are ready with this list, then it will be transferred to our long kappa administrator, Azamat, and he will work on your accounts.
Okay, thank you.
Yeah, you're welcome. So one more question. Are we allowed to team up with people from different lab sections? Well, I'm not sure about that, but this is very specific question, which I believe can only lab assistant answer, because this is their field of activity and responsibility. So they define how these rules for laboratory works are implemented. We can only kind of recommend them certain approaches, but obviously, since they are directly working with you guys during laboratory works, they will try to organize this in the most efficient way for them and for you. So let's see what can be done. So you definitely can raise this question for your lab assistant. However, it may be some complication because of forming groups from different sections. Then it will involve two lab assistant to evaluate it. So it will be kind of complicated situation. Probably we want to avoid any sort of arbitrary, artificially created difficulties. taking into account how many students we have currently enrolled in our course, it's around 800. So it's really a challenge to manage efficiently such a big course. Okay, any additional questions? Good. So as you already know, and this is probably the minimum requirement, what you need to know, that we are going to study physics. Physics is the science of like studies the fundamental principles of nature, trying to explain why things are happening this way and not another. Obviously it is. So another question is, did you say first meeting? Yeah, it's available via that link, which I sent you with the welcome letter. So all our online meetings will be recorded and available for you afterwards online in any time which is convenient for you. Physics is by nature of the approach of studying physics is divided into experimental and theoretical physics. Obviously, it started from experimental, empirical experiments. So empirical experiment is experiment which we can observe as external observer. So at the beginning, it was not intentional experiment. It's just observing nature around us and realizing that there are certain chains of reasons and consequences. And over time, how it evolved, we developed some mathematical apparatus which allowed us to describe quantitatively those observations which we did in our everyday life, or later which we designed intentionally. So initially we observe nature and develop mathematical equations in order to describe what we see. But then at some point of the development of theoretical physics, it comes to the point when it is possible to predict certain physical phenomena and processes based on our previous knowledge and these quantitative models which have already been developed. So that is the main purpose of theoretical physics. First, explain observed experimental results. Second, which is probably the highest level of achievements in theoretical physics, predict new physical phenomena. And hopefully over time, there will be certain group of experimentalists who will design experiment in that way that it's possible to prove this theory and show, yes, indeed, this phenomena exists, or it, if it's already known, it follows to certain dependencies which are predicted by this theory. So this is the closely connected tandem of theoretical experimental physics. For instance, I am an experimentalist. My field of research is physics of semiconductors and semiconductor devices. In particular, I'm working with organic electronics and optoelectronic photovoltaic devices. So organic means I work with organic semiconductors, which are called another way plastic semiconductors. So we are accustomed that plastic is kind of a dielectric material, doesn't conduct electricity, and used quite widely as insulator in electrical wires and electrical circuits. However, depends on chemical structure of this organic molecules. Certain plastic materials can conduct electricity and absorb light, create charge carriers, and those photo-generated charge carriers can certainly be collected by electrodes and do some useful work. For instance, by using organic or plastic solar cell, we can convert sunlight to electricity and then use it for our purposes. So that is short information about my background. So I believe it makes sense to know who is your instructor in terms of like theoretician or experimentalist. Definitely, I have this vision of physics from the side of experimentalist scientist, and that probably will also have some impact on my style of teaching. So we will deal during, as I mentioned earlier, during this semester, we will deal with mechanics, molecular physics, and thermodynamics. So these are three parts of general physics, which are like fundamental blocks of physics and mandatory for understanding, because quite many concepts which are introduced in these courses in these fields of physics, they have impact on other like more sophisticated fields of physics and let's say more modern fields of physics. However, mechanics is always mechanics. It's classical part of physics, but it will never get old, because mechanics surrounds us in everyday life always, and we definitely need to understand how it works. So in mechanics, we will work with three main physical quantities. Do you have idea which are those?
Mass, speed.
I mean, that is already the derivative. So we are talking about some
Distance and time.
Yes, exactly. So mass, distance, and time. So because as you may already clearly see from this list, like speed could be already a derivative of two of these three. So distance divided by time gives us the speed. But like three fundamental physical quantities are mass, time, and distance. So we will deal with them, and it is necessary to understand that they also, since this we call them physical quantities, means that they have some dimensions. Dimension is actually definition of physical nature of a quantity, because quantity can be any. So you can provide any numerical number, say, okay, this is some number, it's some quantity of what we don't know if it doesn't have dimension. However, when we already provide dimension, we automatically put some physical nature behind this quantity. So we call it physical quantity. And don't miss this with units. That is important point, because, for instance, distance between 2 points can be measured in meters, centimeters, inches. So it all will be correct. So these are units. However, the dimension of this quantity like distance between 2 points, will be distance. And that defines what we actually deal from the physical point of view. So since we have this definition of dimension, which provides physical meaning to a quantity, automatically we come up to the next very important statement, that dimensions, when we have some equation with left and right side, and left and right side of this equation, it can be either just one number, or it can be some complicated equation, left side, and then another different one from the right side. They should possess the same dimensions, because in physics, we cannot put equal two quantities which have different physical nature. So it doesn't work like this. And it kind of makes sense on intuitive level. So we can compare distance with distance, and it doesn't make sense to compare distance with time. So taking into account this fact, it's very useful actually, and practically used quite often by physicists in order to double check if their calculations, the derivation of some new equations were correct. Because there is definitely, if you derive some equation, you do it on purpose, not because you have nothing to do and just do it for fun. However, that could also happen. But usually you want to get equation which gives you some physical quantity and like some physical parameter. So you know what is from the left side, this physical quantity. For instance, you want to derive equation for speed, and speed, like dimension of speed is distance divided by time. So you know what is in the left side, and you need to know that your right side, doesn't matter how complicated this equation will be and how many parameters and terms will be involved. The dimension of this equation should be equal to the dimension of speed in our example, or any other physical quantity which is in the left side. If it's not true, if you carried out this dimensional analysis, so-called, and you see that you end up with something similar, but not exactly distance divided by time, there is something else, then of course you made a mistake. And it's way better to figure out this mistake, try to find the reason for it and get a correct equation, than to just apply this equation and get wrong answers. Then you really don't know why you got these wrong answers. Either you made a mistake while deriving the equation, or just technical mistake while substituting numerical values into your equation. So which can happen both, and need to be very careful in both cases. But this is dimensional analysis. It's the key requirement for double checking your derivation of equations. Okay, let me change the camera now. Let's see how it works. Okay. And if we want, so let's say we have some, physical quantity. Again, let's take an example of speed. In order to write this, its dimension, we need to put it in this square brackets. It's equal, and in our case, it's distance divided by time. So again, here we can just write down three main physical like dimensions which we are going to operate with. It's mass, distance, and time. So this fact that the left side and the right side should have the same, like, equal dimensions is called dimensions homogeneity, and it can be written in such form. Let's say we have some left side equation. It's mass in the power of A, L distance in the power of B, time in the power of C. So here on the right side, we have another combination of this mass, distance, and time, but in power X, L in power Y, and T in power Z. So according to this statement that left and right side of the equation should possess the same dimensions, we can write that A is equal to X, B is equal to Y, and C is equal to Z. So this is the rule which we can apply for any derived equation and double check. So when we deal with dimensions in such form of equations, in the scope of dimensional analysis, we should treat them as some algebraic numbers, and that allows us to do actually a bit more of use this dimensional analysis for some estimation purposes. Let's say consider such an example. First, let's make it very simple, and then maybe we'll consider one more, which is a bit more interesting. So some position of the body, we know that it is proportional to acceleration and time. However, let's say it's not clear in which power this acceleration and time should be. So let's put here acceleration A in the power of n and time t in the power of m. We know that dimension of this position is L, distance. And we can write it also in another form. It will be L in the power of 1 times t in the power of 0. So we can put in the power of 0 anything, because anything in the power of 0 will give us unity. So at the same time, we need to know what is the dimension of acceleration. So dimension of acceleration is L over t squared. And now we can write actually this algebraic equation for the dimensional analysis for this particular case. So what do we have at the left side? We have L in the power of 1 times t in the power of 0. So this is equal to L over t squared in the power of n times t in the power of m. So let us open this parenthesis, and we will get L in the power of n times t m minus 2 t in the power of m minus 2n. Okay, so we have L, t, distance and time dimensions from the left and right side, means that their respective power should be equal between each other. So n is equal to unity. We already see it from here. And for the power next to time, we can write that m minus 2n is equal to 0. So from here, taking into account that n is unity, we can get the value for m 2n, and this is equal to. So eventually we get, with the help of this dimensional analysis, let's write it here, we get that x is proportional to a times t squared. So this is quite close to the true case. So definitely it will give us some order of magnitude, because dimensional analysis can provide us with equation only with some missing constant. So we cannot be like claim that this is the right equation. We cannot write that x is equal to a times t squared based on our dimensional analysis. So we can write that it's proportional. However, as you may know, but we will consider
initial velocity.
Sure, but we deal with acceleration. So of course it is proportional to initial velocity, but if you assume that initial velocity is equal to 0 and you have just acceleration, like constant acceleration, so that will be the case. And if again we have constant acceleration, this a is constant, then the accurate equation will be a times t squared divided by 2. So you see that just with the accuracy of this 1/2 coefficient, we get the equation for position as a function of acceleration and time, purely based on dimensional analysis. Now let us consider one more example. And let's say we have a star, and we can measure two parameters from observation of this star. We can measure for sure only two parameters. First parameter is the mass of the star. Second, its radius. So we know only two parameters about this star. And we need to estimate. So very often we don't need to calculate accurately. Quite often happens that it's enough just to estimate the value of certain physical quantity, because it can help to make a conclusion for the future steps, if they are reasonable or not. So let's say we want to estimate the pressure inside this star. So we have mass of the star and radius of the star. Pressure we want to estimate. Obviously, so what can we do now? Let's say pressure, since we estimate, we want to put this like proportional sign. And obviously, the bigger the star is, it could have impact on pressure, the larger radius is. And of course, the larger mass or smaller mass, it will also have impact. So these two parameters are, which we only can measure by observing the star, they are definitely relevant parameters for defining this pressure. So we can say that pressure is proportional to mass and radius of the star. And obviously we need to add here, since its pressure is about gravity. Why do we have it? Because we have some gravity, and this mass of the material of the star puts some pressure on its center, on its core. So here we add this universal gravitational constant, G. And in terms of dimensional analysis, we can write the following, that dimension of pressure, which we will write down a bit later, should be equal, because it's from the left side of this equation, to the dimension of the right side. And here it will be dimension of universal gravitational constant in the power of x, because we don't know in which power it will be. Even we don't know if it's going to be proportional or reversely proportional. So this power could be positive or negative. So we just don't know and just put some unknown parameters here, x, y, z. So here we have dimension of the mass of the star in the power of y, and times dimension of the radius of the star in the power of z. So now we have all this, and next step, we need dimensions of each of these parameters involved. So let us write it down. Dimension of pressure is mass in first power times distance in minus first power times t in minus second power. Then dimension of the gravitational constant will be mass in the -1 power, distance in the power of 3, and time in the power of -2. One more parameter, actually two more. It's mass of the sun, but that is just mass, and radius of the sun. And what is dimension of radius of the sun?
Kilometers.
Oh, that is units in which you measure. You can also measure in meters.
Just radius.
Radius, its dimension is distance, L.
Yeah, distance.
Yeah. So kilometers could also be, but that's just unit of measurement. So that is important not to to feel the difference between dimension and units. Okay, so now we know already all these dimensions. We can substitute them in this equation, the dimensional equation. So let us do it. Mass times L in the power of -1 times T in the power of -2 is equal to mass in the power of -1 times distance in the power of 3 times time in the power of -2, and this in the power of x, according to our equation here. Then times mass in the power of y, and times distance in the power of z. Okay, so now we can open this parenthesis, and we'll get the following. Will be mass minus, so what we get here will be mass in the power of -x, and here is mass in the power of +y. So it will be mass in the power of -x plus y. Then we have distance L. Here is power 3x. And then we have also L here with power of 2. So it will be 3x.
No, it's the power of z.
Oh, sorry. You are right. Exactly. That's my problem, that I cannot distinguish my 2 from z. My writing is not so perfect, so I'm sorry about that, but you will be accustomed. So here we have z, 3x times z, and then times t. So we don't have t outside the parentheses, so it will be just minus 2x. Okay, so now we have left side and right side. We know that the power of for each of the dimension should be equal. So we can write a set of equations, like a set of 3 equations. System minus x plus y will be equal to 1. So we have this is equal to this. Here is just 1. Then 3x plus z is equal to minus 1. And minus 2x is equal to minus 2. So with this system of 3 equations, it can be easily solved for x, y, and z. We have 3 unknowns, 3 equations, so no problems to solve. So x will be equal already from this bottom equation. You will see that it will be unity, like 1. Then y is equal to 2, and z is equal to minus 4. So eventually we can write that pressure inside the star with given mass and radius. Sorry, that's not correct. We don't put equal. We put is proportional, because for sure with certain constant we will not get the accuracy. There will be G, universal gravitational constant, times mass of the star in the power of 2. So x is unity, so G without any power. Then y is 2, so mass in the power of 2, and z is minus 4, means we put this time in the denominator. Sorry, the radius of the star in the denominator are a radius of the star in the power of 4. So we get the estimated, can get estimated value of pressure inside the star. If we consider, obviously the most known star for us is our sun, that the mass of the star of the sun is equal to 2 times 10 to 30 kilograms, and radius of the sun is 7 times to 8 meters. We get this estimated pressure about 10 in the power of 10 bar. So bar, who doesn't know, it is is pressure of our atmosphere at the sea level, and it's something like 101,000 of Pascal. So this is the way how you can use dimensional analysis for estimation of physical quantities, which you don't know much about. So you know only certain important parameters. However, you don't have a model which describes this physical quantity which you want to know. But using dimensional analysis, it can definitely help you to get some estimation of its value, which is really great, and definitely should keep this in mind and use when it may help you. So at this point, we need to finish our meeting because—
Sorry, I have a question.
Well, yeah, can you repeat?
From where did we get these powers in the initial powers? I mean, like 1, -1, -2.
I agree. Yes.
You mean these
Yes, yes, yes.
dimensions? Oh, so we haven't yet studied these topics of like pressure and gravitational constant. But if you check like just dimension of this parameter, so if you write dimensional equation of gravitational constant, so you definitely can get this, and it just comes from the physical meaning. So as I mentioned, dimension describes physical meaning. If you know physical meaning of these parameters which you deal with, so that means automatically you should already know the dimensions of these parameters. So here for this example, they are just given because we didn't study them, but we just show how we can use them in dimensional analysis in order to come with some estimation equation.
Okay, thank you.
You're welcome. So there is some question in the chat, like mass. Oh, sorry. Yeah. So let's check what is written here. Acceleration. So the dimension of acceleration yeah, but dimension of acceleration is like units of acceleration is meter divided by second in the second power, but dimension is distance divided by time in second power. So again, need to distinguish between these two things because you can measure acceleration also in centimeters per second square. So that is the unit. However, dimension of acceleration will not change. It will be always the same because it is definition of your physical meaning. And yeah, you are right. These are the description of units of pressure in the next comment in the chat. Again, these are units. Keep in mind because it's all correct, but you need to substitute for kilogram mass for meters distance and for seconds time, because again, you can measure pressure in different units. And we already even discussed this shortly in our example, because as you see, we can present pressure in bars, which is quite common in industry and also in pascals and other units. So like kilograms per meter per second square. So all these are units, they can change, but dimensions remain the same and define the physical nature of the quantity. Okay, thank you very much for your attention. Was nice to see you guys again, and hope to see all of you on Friday at the same time. So have a good day and take care.
Thank you. Goodbye.
Thank you.
See you.
Thank you. Goodbye.
Thank you.
Bye.
Goodbye. Thank you.
Bye.
Yeah, bye-bye, guys. Bye.